Hey guys, you know those Allstate maintenance alerts you signed up for?
Here is the rotating globe of Mars, and we're going to zoom in on the middle southern latitudes, the part of Mars where we find these active slope features, and we're zooming in on the Newton Basin crater here. What you can see are lots of gullies. The active features that we've recently discovered are on the slopes that are facing mostly to the north, to the equator. What we see are much smaller scale features than gullies. You can see an area of bedrock, a steep cliff here, and it's from that bedrock that these dark features flow out. Given the latitude and the slope aspect, in particular the temperatures, it suggests that there is a volatile involved here, and the appropriate volatile for this temperature is water. Probably salty water, because sometimes these are active when it's a little bit below the freezing point of pure water. Salt lowers the melting point. And water on Mars should be salty. We know there's lots of salts on Mars. This is potentially actual water in a liquid state flowing on Mars today, not millions of years ago. And in late spring and into the summer is when these features form and fade. By late summer, early fall, they'll be completely gone, and we'll see just a normal looking slope throughout the winter. Every place where we have multiple years, these features recur. They're not exactly the same. They may be more or less active one year than another, but they keep coming back.
Okay, let's see, I just wanted to look at where these observations were actually made. Okay, so you can see that we're talking about kind of a mid-latitude on Mars, not too far from an area where we have landed a lander, but we don't have any lander view there. And none of our landers are like high-performance, rocket-powered things that can actually traverse hundreds of thousands of kilometers. So we're basically stuck where our rovers are, and none of them are close enough to look at that. But we have plans to go look at that, because you can imagine the potential there. If you're talking about liquid water actually on the surface, who knows what might be in that liquid water. It could be connected with some subterranean area where microbial life could actually still survive. So that was another major discovery that was completely unexpected and was only found at random because somebody happened to be looking at this image and actually looked at it a few months apart and noticed that these streaks had actually changed. So that is an unprecedented thing to actually see a water cycle on another body other than the Earth. Okay, so again, just to talk a little more about these nearby Earth-type planets, we have one of the closest ones here is actually an Earth-type planet, but not an habitable zone. As I talked about last time, if you're not in the habitable zone, it's going to be too hot or too cold, so you're not going to be able to have that water cycle. This particular one is about 50 light years away, 14 times the mass of the Earth, quite close to its star, much closer to its star than Mercury is to our sun, and very hot because it's very close. And the surface gravity, it's a bit larger in radius than the Earth, but it's 14 times the mass of the Earth. So if we work out the surface gravity, which we're going to do for different planets that we talk about, it's about 2.5 times Earth's surface gravity. So that means that the force exerted on your body on this planet will be 2.5 times larger, right? So if you're standing on a scale has a spring in it, and the spring works the same on Earth or that planet. So if it's a spring scale and you stand on it, your weight's going to be 2.5 or 2.4 times higher. So that led to some speculation that dieting would be popular there. And so it's been named Planet Atkins at the moment. I actually thought South Beach would be better. Atkins is a little dated now. And we now know that on further telescopic observation that cars actually aren't allowed. So that does go with the Atkins theme there a little. All right, so now we're really getting kind of into the meat of what we're going to be talking about in Chapter 1 for the rest of today. Earth's place in space, which is characterized by the motions of the stars that we see, which are actually entirely due to motions of the Earth as it spins and as it orbits around the sun. The most basic phenomenon that we recognize when we look in the sky is, of course, the rising and setting of the sun, but all the stars also rise and set in a 24-hour cycle that we call diurnal motion, everyday motion. So this is an image here where we're looking toward what we call the North Celestial Pole. We're looking north, and we leave our camera shutter open for a certain amount of time. Now, a full spin here, these are star trails caused by leaving the shutter of the camera open, so we can see a full spin in 24 hours. So when we see a little arc like this, it's about a third or so of rotation. So this is about an 8-hour exposure, roughly. So this is the result of taking your camera, nothing particularly fancy about the camera, just pointed at the North Celestial Pole, and which is an extension of Earth's axis into space, and we just let it record. We just leave it open. It has to be, of course, very dark, or the camera image would be fogged by light from cities and things like that. So just to give you another idea of how we can visualize this, kind of a crappy little demo thing. Okay, so we have somebody looking up at the sky, and what we're seeing is a rising and setting phenomenon, but now we can see that what's really going on is that the Earth is spinning. The stars are not moving, essentially. It's all due to the spin of the Earth, which is counterclockwise as viewed from above the North Pole. Okay, so again, if we look down at the North Pole, there's the North Pole. Run away. There's the North Pole. So if we're looking down on that, you can get a sense of this is a counterclockwise rotation. And it's that counterclockwise rotation that causes the stars to appear to set in the east. If the rotation were reversed, things would rise in the west instead of in the east. So the whole phenomenon of diurnal motion is basically a reflection of Earth's spin. This is slightly better. So here, this is a simulation, but we let sunset occur here, and we started seeing stars. And it's a time lapse, so we can see in the east things are rising. The Earth is really spinning counterclockwise, hence things appear to be rising in the east. We actually see a little bit of haziness there, which is the Milky Way, which probably isn't translating on your screen very well. Now we pivot north. Now we're starting to see this phenomenon of the North Celestial Pole I was talking about, because there's a point in space that we're looking at now, right around here, that everything seems to pinwheel around. And if you think about it, such a point would exist because it would be on the axis of Earth's spin motion. If we extend Earth's spin axis into space, we're of course going to see the rising and setting turn into arcs around that point. And what we're actually seeing is a type of coordinate system that we're going to talk about. Because we have this rotational motion around the North Celestial Pole, it's really hard to read it. See it. There's the North Celestial Pole. Stars actually ride on this grid. So this grid is sort of like a latitude-longitude grid. It's what we're going to call celestial coordinates when we get into a little more detail on this. But basically, it acts like latitude and longitude, and what we're seeing are these rings, which are rings of constant, what we would think of as latitude on Earth, but we actually have a different name for it in space. We call it right ascension, or actually declination. But anyway, the whole reason that coordinate system is invented is because stars will move with it. Like this star right here is moving with that coordinate system. So even though the motion is occurring, a star's actual coordinates don't change because the coordinate system is set up so that it actually spins as well. Okay, and there we have sunrise on another peaceful day in America.